Okay, good morning. So today we're going to be talking about solving inequalities. Now, inequalities are extremely similar to equations. The only difference between equations and inequalities is the equal sign or the inequality symbol. Okay? When you're dealing with equations, you're talking about an equal sign. Very, very easy. When you're talking about inequalities, though, it's not exact. Inequalities are going to give you a range. The variable that you're solving for could be greater than something or less than something or greater than or equal to something or less than or equal to something. So inequalities use the greater than sign or the less than sign, and then the greater than or equal sign or the less than or equal sign. A couple little notes for when you're reading inequality type problems. When they tell you something like 4 more than a number, please remember that 4 more than a number is just x plus 4. So the confusion comes with, when do we know that they're talking about more than inequality? Well, let's think back to how we used our words for mathematical relations. What does is or was or were represent? Equals. Very good. Is, was, were, that's equals. So in order for the inequality to be activated, you need an is in there. Now, what am I talking about? A number is greater than 4. Do you see here how I have the is greater than? That is indicates inequality. So that in this case, this would be a number x is greater than 4. Big difference. So if it says is greater than, boom, greater than. Is less than. Is greater than or less or equal to. Is greater than or equal to. Is less than or equal to. Okay? Now, not only do they use the is to indicate inequality, but sometimes they'll do this. Is at most or is at least. That's a big one for most of my students. They always get confused. So they tell you is at most. I always like to think about this with age, okay? What would you guys say my age was? What would you think my max age is? 35? Okay, thank you. That was very kind of you. So Mr. Morrow is at most 35. So Mr. Morrow is at most 35. What does that mean to you guys in your own words? Yes, sir. Yes, sir. Danny, yes, sir. No, he said that Mr. Morrow is greater than or equal to? No. I'm at most 35. Yes, so that means Mr. Morrow M is less than or equal to 35. I'm at most 35. That's the max, right? Now, what would you say my minimum age is? Mr. Morrow is at least 30. Okay. Bless you. So Mr. Morrow is at least 30. What does that mean to you in your own words? I'm at least 30 years old. Very good. Mr. Morrow M is greater than or equal to 30. Because remember, when you're talking about at most, it's also an equal. And at least, it's also an equal. So please make notes of that, please. It's very important. None of this is in the lesson either. It's not in the book. I just like to give you these little pointers because as we go on through the chapter, you're going to have more word problems, and we'll go from there. As far as the word problem worksheet, I know some of you are having problems with that. We're going to try to hit that today if we have time. If not, don't worry. We're going to finish up the chapter with inequalities. We're going to have a test on inequalities and absolute value, so another test. And then I'm going to show you some more word problems. So we'll go back to your word problems and add even more difficult ones. Okay? So don't stress about that if you're stressing. Okay, so now let's talk about, before we talk about solving, because it's so easy, let's talk about graphing. When we're graphing solutions, okay, once you have the solution, guys, you have to be able to graph it. So there's a couple indicators that you guys should know about. I'm going to talk to you about some things that aren't really in this book yet. And I hate to do it to you, but I have to. Okay, I got to show you everything. So we're graphing inequalities. Excuse me. Okay, sorry about that pause. Okay, so when we're graphing inequality solutions, you got to know what the symbols mean and how to identify that on the graph. If we have a greater than or a less than, you're going to use an open circle. Okay? If you're using a greater than or equal to or a less than or equal to, you're going to use a filled in circle or dot. All right, so that's the first key. If it's less than or greater than, that means that that number is really not included in there. If it's greater than or equal to or less than or equal to, then it is included in there. Now, let me show you what I mean. Let's go ahead and just put a number line out here. Make our lives easy. Okay. Let's say I tell you that x is less than 5. Okay. We're going to locate the 5. Now, is the x equal to 5 or is it less than 5? Less than 5, right? So we're going to use an open or a closed circle. Open circle around the 5, that indicates to any mathematical reader, hey, 5 is not included in this. But x is less than 5. So we are going to graph all of the possible values that represent that x. How can we represent all of the values that are less than 5 here? That's absolutely right, son. So you go ahead and shade to the left. Nice big arrow showing the reader I'm going to the left. That is x is less than 5. Yes, sir. Okay, on a test, on a quiz, I would accept this. 0, 5, open circle to the left. I'm not here to torture you. Want to make sure you understand what it means, though, sir. Thank you for asking. Now, let's say I tell you, I'll do it in a different color. Let's say I tell you x is greater than or equal to -2. This time it's greater than or equal to. So am I talking about an open or closed circle? Yes, sir. Very good. So where is this closed circle going to be on, my man? Yeah, absolutely right, sir. So closed circle on -2. Now, we're representing the value of x. Always read from the variable. Always read from the variable. Always read from the variable. So my man, you've been doing great on this. X is greater than or equal to -2. How do I represent that here? So to the left or to the right? Awesome, my brother. So it would go that way. On a test or a quiz, you can go 0, -1, -2. Closed circle, it's greater than, so you got to shade it to the right. Does that make sense? Do we read from the number or from the variable? From the variable. Less than or greater than uses an open or closed circle? Open. Less than or equal to or greater than or equal to uses a closed circle. Very good. Now, as far as Yes, sir. Thank you.
Sometimes when I took it up to solve it, would be the correct.
Correct, sir.
Sometimes if it's five, if you had five is greater than x,
If you had 5 is greater than x is
no, if you had five, if five was first, would
okay, it doesn't matter if the 5 is first. That's why I said read from the variable. The question was, if I had this, isn't that 5 greater than x? Technically, but do we read from the number? What did I repeat 4 times in a row here? I said, no, don't tell me what you're saying. Repeat what I'm sorry, answer my question. I said to read from the variable. Does it matter what side the variable's on? No, sir. So you read from the variable. So this would be x is less than 5. Open circle on the 5. Less x is less than 5. You never read from the number. You always read from the variable, sir. Does that make sense, son?
yes. That was our answer. Would you like us to switch it around?
Okay. You're asking the redundant question again. The question was, if this was your answer, do you want us to switch it around? Be careful with that. Most people are going to do this. Would that be the correct switch around? No. That's why I don't like teaching switch it around so that the variable's always on the left. The real switch around here would be x is less than 5. But it doesn't matter. It doesn't matter what side the x is on. What matters is, are you reading from the variable? Does that make sense, then? Does that answer your question? Thank you very much. Does that make sense for everybody so far? Okay, great. Thank you very much. Okay, now, when we're talking about actually solving inequalities, if you guys know how to solve multi-step equations, which I'll be nice and go over the steps again. First, undo all distributive property. Second, combine like terms on both sides. Third, bring all the variables to one side. Fourth, undo addition and subtraction. Fifth, undo multiplication or division, and you're done. Everything is exactly the same. Follow procedures for solving equations except, I just spelled that wrong, didn't I? Yes, I did. Except when you multiply or divide by a negative. Let me explain. If I've got, for example, negative 5x is greater than 10. How do I solve for this? Divide by negative 5. I'm dividing by a negative, correct? By a negative. Whenever I multiply or divide by a negative, I flip the inequality sign. So this answer would be x is less than negative 2, open circle, shaded to the left. Because I multiplied or divided by a negative. Very different than multiplying to a negative. Let's say I had x over 5 is less than negative 2. How do we solve for this? Sir. Very good. So you're going to multiply by a reciprocal of 1/5. So you're going to multiply by 5 over 1. My friends, did I multiply by a negative here? No. So do I switch the inequality sign? No. So only when I multiply or divide by a negative do I flip the inequality sign. Does that make sense, everybody, so far? Awesome. I see some people writing, so I'll let you finish that up, and then we'll do some examples. You ready? Okay, my brothers. Let's see what we got here. Let's look at some examples. Okay, for example 1, it says, what inequality represents the sentence 5 fewer than a number is at least 1 point, oh, I'm sorry, not 1.2, but 12. Okay. 5 fewer than a number is at least 12. How do we write this? Yes, sir. 5 fewer than, flip, great job. So x minus 5 is at least, what did we say at least was? Greater than or equal to, great job, son. 12. Done. What variable do we want to get all by itself here? X. How do we get that x alone? Add 5 to both sides. That's absolutely right. 100%, my brother. X is greater than or equal to 17. Boom. 0, 17. Open a closed circle, my brothers. Am I going to go to the right or to the left? To the right. Do I read this from the 17 or from the x? How do we read this? X is greater than or equal to 17. Fantastic. Does that make sense? Awesome. We're good? We're still going to do some more examples. Excuse me. Sorry. A little bit of a cold. May I continue, gentlemen? Okay, thank you. So another example. How about negative 3 times 2x minus 5 plus 1 is greater than or equal to 4. All right. Mickey Mouse time is over. Let's get to work here. What are the first steps of a multi-step equation or inequality? Yes, sir, my man. Distribute, thank you. So that's going to distribute. So negative 3 times 2x is negative 6x. Negative 3 times negative 5 is plus 15. Plus 1 is greater than or equal to 4. Second step, combine all like terms on both sides. So I got negative 6x plus 16, because 15 and 1 were like terms. It's greater than or equal to 4. Now I want to get that x alone. I got a two-step equation. What do I do, my man? Subtract 16 to both sides. Very good. So I got negative 6x is now greater than or equal to negative 12. Remember, when you have the opposite signs, you subtract as normal. Keep the sign of large absolute value. Now, how do I solve for x here, my brothers? Yes, sir? Divide by negative 6. Am I dividing by a negative here? What do we do when I divide by a negative? Flip the inequality, and that's 2, 0, 2, less than or equal to, closed circle, shaded to the left, ding dong, the witch is gone. Yes, sir. Did I say when you subtract by a negative number, you switch? Or when you multiply or divide by a negative number, you switch? When you multiply or divide, so subtracting means nothing for switching the inequality sign. Thank you, sir. Yes, sir. I subtracted 16 to both sides. What's 4 minus 16? Negative 12. Yeah, when you're subtracting numbers that are opposite signs, you subtract as normal, large minus small. Yeah, on the test, you guys did that wrong. It was like 1.82, and then you went minus 6.4. That's where you guys did it wrong. You have to go 6.4 minus 1.82. So no, on the test review, that's exactly what I told you to do. You got to subtract as normal. Large minus small, and the sign goes to the largest absolute value. I would suggest watching my video on integer operations again, sir. Would be my suggestion. Okay, does that make sense, people? Hello?
Yes.
Okay. Now, real quick, because the bell's about to ring. Just want to just show you how to apply this real quick. A movie rental company offers two subscription plans. Oh, real quick. You can pay $36 a month to rent as many movies you desire, or you can pay $15 a month and $1.50 rent to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? First plan was $36 a month. When will that be less than the second plan of $15 a month plus $1.50 for every rental? Okay? Then you would solve from there. May God bless you. Have a great day. And real quick, I'm sorry, that's just 36 because we're talking about 36 months. So there's 36 months, less than 15 months plus 1.5 videos. $1.50 per video. Sorry about that. Thank you.